So we have a question here that says we need to prove these two De Morgan's laws that we have here. So we start with the first one. So here we have B intersection C complement being equal to B complement union C complement, like this. So then we're going to prove from the left hand side to the right hand side, and conversely we also prove from the right hand side to the left hand side. So we're going to let X be a member of what we have on the left hand side here. So we say let X be a member of B intersection C complement, like this. So then if X is a member of the complement of the intersection of the two sets here, then X doesn't belong to the intersection set that we have here. So here we're saying X here does not belong to, or is not a member of B intersection C, like this here. So now, before we proceed, let me just mention something. So when we're proving De Morgan's laws here, and is the intersection, then for O we use it for union there. Okay. So now this simply just tells us that X is not a member of B, and X is also not a member of C here. So we're going to write that, saying X here is not a member of B, and X here is not a member of C. So then if X is not a member of B, then X is a member of B complement. So here X is a member of B complement. So the moment we change from saying X belongs to something to X not belonging to something, the weight that we have on the middle here changes. So we're saying the moment you change X not belonging to something and it belonging to a given set there, then the weight that we have here changes. So here we're saying X belongs to B complement, or from and we go to O now. So X belongs to B complement, or X here belongs to C complement, like this. So now here X is a member of B complement, or X is a member of C complement. So you can just join the two here with what we have this side. We say that if the weight is O, then we use the symbol for union. So this simply tells us that X is a member of B complement union C complement, like this. Let me just scroll down a bit. Okay, so now if X is a member of these two here, so this simply just tells us that B intersection C complement is a subset of B complement union C complement, like this here. So we're going to name this one there. So conversely, we need to prove that the left hand side is also, or the right hand side is also equal to the left hand side there. So let's say conversely here, we let X be a member of what we have on the right hand side, which is B complement union C complement, like this here. So if X is a member of B complement here, then we can just say X is a member of B complement, or X here is a member of C complement, like this. So then we have that X here. So now if X is a member of B complement here, then X is not a member of B. So we just say then X is not a member of B, like this here. So we've changed from X belonging to a given set to X not belonging to this set at all. So meaning that we also change the weight that we're using on the middle there. So here we're going to say and X is not a member of C here. So this simply just tells us one thing: if X doesn't belong to B and also doesn't belong to C, then X doesn't belong to B and C there. So then here we're saying X here is not a member of B intersection C. So if X is not a member of B intersection C, it just simply tells us that X is a member of the complement of the set that we have here. So here we have x here is a member of B intersection C complement like this. So then this just shows us that B complement in union, let me use union there, sorry. Okay, so this just shows us that B union C complement is a subset of B intersection C complement like this. So you can just call this one, or we name it as equation number 2 or something like this. So now, if you look at these two here, we've proved that the left hand side is equal to the right hand side, and also that the right hand side is equal to the left hand side. So therefore you can just conclude here. You can just say from 1 and 2, it holds that so from 1 and 2 there we can just say it holds that B intersection C complement is equal to B complement union C complement like this here. Okay, let's go to the next one. So for the next one, which is the second one there, we have B union C complement is equal to B complement intersection C complement like this. So we do the same like we did in the previous one there. We start from the left hand side, going to the right hand side. Then we also start from the right hand side, we go back to the left hand side. So if we can prove that both ways are equal, then we've proved the demograms there. So we let x be a member of the left hand side, this side, which is B union C complement like this. So now, if x is a member of the complement of the two sets that we have here, then x doesn't belong to the union of the two sets. So this just tells us that x here is not a member of B union C like this here. So now, if x is not a member of this here, remember what we said about union and intersection. So here we're simply just going to say x is not a member of B, or x here is not a member of C like this here. Let me just scroll down a bit. Okay, so now here we have x here is a member of B complement. So if x is not a member of B, then x is a member of B complement. So the moment we change from not a member of to a member of, we also change the word on the middle there. So this now becomes and x is a member of C complement like this here. So then this just simply tells us that x here is a member of B complement intersection C complement like this here. So then therefore we have that B intersection C complement is a subset of B union C complement like this here. So we name this one as 1 here. Then we also need to prove the other way around. So now, conversely, we let x be a member of B complement intersection C complement like this here. So now, here we can just go ahead and change these two words now. So it's this implies that x is a member of B complement and x is a member of C complement. So then, if x is a member of B complement here, then x is not a member of B. So this just tells us that x here changed from being a member of to not being a member of here. So this just tells us one thing. We also need to change this way that we have in the middle here. So from and we're going to change to O. X here is not a member of C. Okay. So now we know that O just represents the union there. So we're going to replace it with that symbol there. So X here is not a member of B union C like this here. So now, if X is not a member of B union C, then X is a member of B union C complement. So here, saying that X is a member of B union C complement like this here. So we have another, so there we can just say B union C complement is a subset of B complement intersection C complement like this. So you can just say this is our second equation there. So since we've proved from the left going to the right and also from the right going to the left there, and they both hold, so you can just say from 1 and 2. It holds that B union C complement is equal to B complement intersection C complement like this. Okay, thank you so much.